Hi everyone, in this video I will talk about the scanning thermal microscopy, in short STHM. Scanning thermal microscope is a technique to obtain thermal information by monitoring and controlling the thermal exchange processes between the probe and the sample. The scanning thermal microscope operates in two different modes, an active mode and a passive mode. In the active mode, which is also called conductivity contrast mode, or CCM for short, the probe in this mode acts as a local heater. It could be heated either by an external laser heating or an internal Joule heating. The mode is also divided into constant current or constant temperature mode. In the passive mode, which is also called temperature contrast mode, or TCM for short, the probe in this mode acts like a temperature sensor with minimal heating power dissipated. These two modes also differ in measurement. In the active mode, it's useful when the sample's thermal conductivity K or Seebeck coefficient is our desired. Also to perform surface lithography using special high temperature techniques. While in the passive mode, it's useful to measure and analyze the surface temperature distribution. Scanning thermal microscopy can be operated in two modes, the contact and the non-contact modes. In the contact mode, the tip is in soft contact with the surface of the sample, but in the non-contact mode, the distance between the surface and the sample is in the order of 10 to 100 nanometers. One example of operation of the scanning thermal microscopy is in both the contact and the active modes. For example, when studying the phase transition temperature for polymers, in this case the scanning thermal microscope tracks both the vertical displacement and the temperature of the sample simultaneously. Let's talk now about the thermoresistive probes used in the scanning thermal microscopes. These probes use a resistor and a metal or a semiconductor. The resistor works as a thermal sensor, while the metal could be a metallic thin film or a belt wire, and the semiconductor is a highly doped semiconductor. In the case of the metal, the material is usually platinum alloy, or palladium. And in the case of a semiconductor, it's usually silicon. Now, let's talk about the working principle of thermoresistive probes. The way it operates is by sending a current, a small current actually, through the probe in order to measure the electrical resistance of the probe itself. The current has to be small enough so as to avoid any self-heating of the probe itself. When the sample is heated, the heat flows from the sample to the probe. As a result, the temperature of the probe increases and its resistance also changes. This can be clarified by the following equation, where a change in temperature would result in a change in the resistance of the probe. Rp is the resistance of the probe at temperature T, Rp0 is the resistance at the reference temperature, T is the current temperature and T0 is the reference temperature. TCR is also known as the temperature constant of resistivity. Some of the challenges in this technique are in the modeling of the heat transfer between the probe and the sample, especially in the contact region. Also in considering the near-field radiation mechanism, and this is very important for vacuum environments. Another challenge is that the characterization of the thermal conductivity is not widely available, and this is because of the temperature difference between the sample and the probe, which is because of the lack of sufficient calibration techniques. There are some calibration strategies that are developed by researchers to address this challenge. The fourth challenge is the fact that multifunctional probes are not improved enough to allow simultaneous measurements, such as chemical and electrical properties, in addition to the thermal characterization. The last challenge is that sometimes inaccurate measurements are produced due to topographical artifacts. This was the end of this video, and here are the references I used. I hope you benefited from this video, and I advise you to watch the other videos by my classmates. Thanks for watching.